So the moon now appears to be the focus of many international space programs, with many countries now planning landings on the moon. So the publicity for the moon missions died down after the end of the Apollo missions in 1972. Further missions like the American Explorer and the Soviet lunar missions continued to visit the moon for many years after that. These missions were mostly taking surveys of the moon from orbit, while other missions were just passing by the moon in order to get a gravity assist from the moon for more distant missions. This included Japan having a couple of missions pass by the moon en route to Mars in 1998. All of these various missions mean that we actually have a lot more information, not just about the surface of the moon, but also about the practicalities of getting it into orbit around the moon than we did in the 1960s. So now there's a data bank of over 100 various missions that have either been to or passed by the moon. Mass media has really been focused on stories about people returning to actually walk on the moon. So it's now over 50 years since the Apollo 17 mission did this. However, coverage generally overlooked the key future planned scientific mission to the moon. It goes under the broad title of Gateway. Now, unlike the Apollo missions, the Gateway project is an international collaboration including NASA, European Space Agency, Japan Aerospace Exploration Agency, and the Canadian Space Agency, and the Mohammed bin Rashid Space Center from the United Arab Emirates. Gateway won't actually be going to the surface of the moon. Instead, it will be using some of the most powerful rockets available to orbit the moon and establish a base actually in orbit from which to conduct scientific research. Now, establishing an orbit around the Earth is relatively simple. Some major issues you have to factor in are Earth's gravity and some minimal atmospheric drag. Orbiting the moon is made more complex by the small mass of the moon compared to Earth's, so setting up a long-term orbit of the moon has to actually account for Earth's gravitational attraction. This makes a standard circular orbit nearly impossible to sustain. Now, said Gateway will be establishing something called a near rectilinear halo orbit. While it may be a mouthful to say, the orbital path is even more complex to achieve. The calculations have to fully encompass the three-dimensional nature of the orbital pathway, as Gateway will be orbiting both the moon, and of course since the moon is orbiting Earth, Gateway will also be orbiting Earth at the same time. This twin orbiting also makes a precise orbital path difficult to describe, as the observer's frame of reference actually matters when describing the orbital path. So when viewed from the Earth, Gateway will perform a large loop around the moon. During that loop, at one point, Gateway will come relatively close to the surface of the moon before arcing away in a broad ellipse, much like the path followed by many of the comets as they come in close to the Sun before going out to the depths of the solar system again. As Gateway gets closer to the surface of the moon, it will also be accelerating towards the moon, so Gateway won't be maintaining a constant velocity. However, to view the orbit from deep space looking back towards Earth and the moon, Gateway will appear to be in an uneven orbit around the Earth, approximately the same distance to the moon, sometimes closer to the Earth than the moon, but mostly being further away from the Earth. The full Gateway mission is hoped to last 15 years. But with these kinds of missions, once the project is actually up and running, with the cost of creating a mission being so very high, when compared to the rather limited cost of extending the mission for a few more years, so if everything goes well, Gateway will actually maybe outlast me. On full completion, Gateway will be smaller than the current International Space Station, in part due to the difficulties involved in getting all the components to the desired location. First parts of the Gateway to be installed will be the power and propulsion element, or the PPE, which will include a substantial solar array which will provide 60 kilowatts of power, which is basically enough for about 30 conventional ovens. To this will be attached the Halo, or the Habitation and Logistics Outpost, which is the initial crew and living quarters combined with batteries, water storage, communications, and other essentials for a manned space station. Once these are in place, a robotic arm will be installed, along with an international habitat containing more crew and living quarters, and with cameras for scientific research. To all these modules, we eventually added a refueling module, a logistics module, which will be used for delivering supplies and handling some external scientific experiments, and with crew and science airlock, which will enable the crew and science transfers, and a further logistics module. Some of these various modules will come with their own independent solar panels to provide additional power for the units. The Gateway is not intended actually to be permanently manned, astronauts will spend a few months at a time in them, and the experiments that the astronauts start on Gateway will continue after they leave and continue to operate whilst the station is unmanned, only to be completed by the next shift of astronauts that actually arrive at Gateway. From the space station, the astronauts will be able to make some spacewalks whilst actually orbiting the moon, which will probably be a fairly unique and mind-blowing experience. While NASA is actually coordinating the Gateway project and funding much of the construction, most of the actual work for the American-developed modules will be done by private companies scattered over most of the United States. It's planned that the full construction of Gateway will be completed in 6 years, but given the special circumstances involved in the construction, my suspicions are that it will take a bit longer. My thinking is primarily down to the size of the rockets being used to deliver the various modules and the complexity of the operation. It's possible that one or more of the launches actually may fail, resulting in the loss of the module being transported, and resulting in a delay while the replacement is being constructed and delivered. In addition, due to the complex nature of all the equipment, along with testing and quality control, may result in some time overruns in actually completing a module. If, as I hope, the Gateway project is successful, there may even be more modules added than originally planned, or even updated or improved modules made available as technology improves during the length of the mission. With so many countries now providing modules or parts of modules when Gateway is occupied, the crew will be changing mix of astronauts from those countries. Given the planned length of the operation, there's always a possibility of one of those future astronauts may actually be sitting at home watching this video. When NASA first started the space program, it was recruiting mainly test pilots and fighter pilots for the astronaut program. However, now most space agencies are far more focused on recruiting scientists and engineers in the astronaut program. So if you think you could be one of those future astronauts, you could check with your local space agency as to how you might go for applying and what actual skills and abilities they're looking for in future astronauts.